How to make a perfect speaker cable. End-to-end tutorial how to make a perfect speaker cable by yourself. And we will cover advanced scenario how to make a multi-channel speaker cable. Before we start to build something, we need to understand the theoretical basics. What does it mean, good speaker cable? Here I took picture from ICEpower engineering manual, where they made the recommendations for speaker cable, and you can see the two separate wires are bad. And we need to understand why. Then, two separate cables close to each other is much better, but still not perfect. And this is typical budget solution. You may find plenty of cables where two cables are put together and with a significant cross-section and sold as a speaker cables. Two twisted cables are excellent. And two cables in a shield also are excellent. But the key question, why? Why this one is very bad, this is kind of okay, and those two are excellent. So let's cover some theoretical electromagnetic propagation principles. And here is our scenario. And the first one, when you have two separate cables, this is single wire scenario, and you can see single wire, when current is flowing through the single wire, you are generating significant electromagnetic field. When you have two wires at close proximity, you have a better scenario because the current flowing through the one wire is generating electromagnetic field in one direction, and the minus or current when it's flowing in opposite direction, it is generating opposite electromagnetic field. And when your cables are twisted, there is a kind of mismatch. Here nothing to compensate, there is partly compensated, and then you have a continuous electromagnetic field direction changes, and it compensates each other. Here is magnetometer, which is measuring some impact or radiated electromagnetic noise, and you can see single wire emission is huge, Then two wires, it's double lower, and when you have a twisted wire, emission is very low. And actually, key reason why you should twist your speaker cables are electromagnetic compatibility. All amplifiers has a high current, and if they have some artifacts or whatever they have, you are emitting significant noise around, and it is received by your audio equipment. Also, it's valid that when you have a single wire, it is receiving a lot of interference and noise from electrical appliances, and in a worst case scenario where you are close to some radio transmitter or even 5G transmitter, all those electromagnetic noises are generating field or generating current in your wire. So when we twist it, we are gaining additional benefit. We are gaining that benefit that it is noise resilient. But the major reason why you should twist is that you and your amplifier is not generating noise in environment. One more side effect from a twisted wire. When you put two wires just flat, they are not staying flat. And when you twist wires, they are staying flat to the surface. The same picture, you can see current is going in one direction and going back, and it radiates electromagnetic transmission, electromagnetic field creates. And when you twist it, total mismatch in both directions, and your emission is a minimalistic. So the key reason why you should twist wires is electromagnetic compatibility. One more thing to understand about your inputs, about your electronic equipment, that there are two types of input circuits. One is unbalanced, and in consumer grade devices mostly we have unbalanced. Unbalanced interconnections are made in a way that you have a hot wire where you have a signal, and then you have a ground, and you have this hot wire reference to the ground. And here is your pressure signal, and when you have a length of cable, and then noise from other equipment are coming to that hot wire, and then both are coming to amplifier, and then you have signal plus noise. Now I would say that for consumer grade equipment, unbalanced connection, interconnection, you can go between 3 to 6 meters, no more. So this is limit. Otherwise you are receiving more and more noise. Another scenario using professional audio equipment, it's a balanced inputs or balanced signal, and you have two hot wires, and those hot wires are not referenced to the ground. Ground is only interconnecting your chassis and making a Faraday cage to reduce the noise even more. Artificially, on a positive wire, we are generating positive phase signal, and on a negative conductor, we are creating opposite polarity signal, reverse polarity signal. And then we have a summing amplifier. One is one input is positive, one input is negative, and then when you summing plus signal and minus means reverse, you are getting double amplitude out. In the same time, through the propagation path, you are receiving noise, but received noise is in the same polarity. And here on a summing amplifier, they subtract each other. And a good summing amplifiers can do some 20,000 times noise subtraction, and you have, for example, here super noisy signal, but output will be perfectly clean. Mainstream amplifiers, summing amplifiers, has a ratio about 1,000 times, not at least 100, but normal ones about 1,000 times. You reduce the noise, and this is very noise resilient pattern. Balanced inputs are much better than unbalanced, and you can go for 10, 20, 100, 600 meters for amplifier interconnection. Even with a microphone signal, you can go for 20, 30 meters. And here we are talking about a millivolts. And here I took one example, how it applies to audio amplifiers. You can see the same picture what we discussed before. And imagine, if you make connections here to the speaker in one side, and from the other wire to other side, we have the same schema. And here our loudspeaker is working as a passive summing amplifier. And when we get such kind of scenario, when we have two wires with opposite signal, it is bridged audio amplifier. And for example, ICEpower 1200 and 2000 AS2 amplifiers, those are bridged by design, precisely bridged. They have 4 separate amplifiers on board, and then they bridge it, and then you have a perfect noise resilient solution. Actually, those ICEpower 1200 amplifiers has very low noise. And also, if amplifier generates some harmonics, then those harmonics are second harmonic is compensated also on a loud. This is so-called quadro-balanced architecture introduced by Macintosh, but in this board it is built by design. I really like this board, and engineers did maximum possible to make it absolutely great. In my opinion, this amplifier is endgame amplifier. There is no shortcuts at any design aspect. It is fully integrated. It has sufficient power. It has this quadro-balanced design. It has a lot of served things. And for home users, it's really endgame amplifier. So the first characteristic of a good speaker cable is noise resilience. When we test it, we are there. The second one is resistance, and you know that speaker wire resistance is function from the distance. Here I took example as a good speaker impedance. So this is impedance what your amplifier sends. It's not just a flat 4 ohms. You can see there is the hills and mountains and downhills, and this particular speaker has a lower speaker impedance of 5.5 ohms. This is 8 ohm speaker, and this is a great 8 ohm speaker. well-designed crossover. And here I took another example, a bad speaker. You can see this also is 8-ohm speaker. We have those resonances as it is with a crossover, but here you have a bad crossover design, and you have a huge dip here on a 2.5 kilohertz, and it's falling down to 3 ohms, and sometimes you don't understand why your amplifier is getting hot or even triggers protection. This is due to the bad crossover design. How the speaker impedance is connected to speaker wires, and you should look at your system as a resistive divider. So you have your amplifier here, and amplifier is a constant voltage equivalent schema. That means if we put 10 volts output on amplifier, it keeps those 10 volts despite of any changes of load. Most of amplifiers are measured on resistive load, but in real life scenario you have this crossover, and crossover has impedance. Impedance is not resistive, it's really complex. And then you have those hills and mountains and drops, everything. Actually, knowing that speaker impedance, you can calculate for each frequency what will be voltage on a loudspeaker, and then you have some amplitude frequency variations. Rule of thumb is that this R1 or wire resistance should be 10 times lower than your speaker lowest impedance. Now, once you have a 4 ohm loudspeaker, then it should be 0.4 ohms or less. When you have very bad speaker, then it should go even lower. And here I took a calculation for a 10 meter long wire with a different copper wire with a different cross sections. And the first one at a 1 square millimeter copper wire, you are getting 0.2 ohms. So that means a normal amplifier minimum cross section wire for a 10 meter distance should be at least 1 square millimeter. In professional industry, smallest cross section is 1.5 square millimeters, and then you get a 0.1 ohm resistance on a 10 meters. And if you want to go for some extreme, then 2.5 is a second standard in professional industry, and then you get 0.067 ohms wire resistance on a 10 meters. 10 meters is extreme. Typically we have about 6-7 meters at home. And what conclusions we can make? That minimum cross section should be 1 square millimeter. If you want some reserve, you can go for 1.5 square millimeters. But often, if you have a shorter distance, for example, 5 meters or 3 meters, this value will drop also by a factor of 3. Do you need a finger thick speaker wires? No, you don't. You can see, even for 10 meters and 2.5 square millimeter wire is giving a fantastic result. I think it's a maximum what you need for a home usage. How about active speaker systems? For active speaker systems, you have a crossover before audio amplifier and using multi-amplifier connections. So for a mid-range, what typically goes from, I don't know, from 300, let's say, to 400, maybe 500. You have very flat impedance. You can use thin wires that will not influence your amplitude frequency characteristics. And this is one of reasons why you get so good results also with a multi-amplifier solutions or active speaker solution, that your impedance is perfect comparing to passive crossover. Okay, we covered some theoretical basics, and let's build multi-channel speaker cable. We also want it easy to use and have the same user experience as dealing with a single channel speaker cable. So here I have my cables. I was looking for a 60 volts cable because it has a thin insulation. I didn't find it, so I'm using 220 volts cables. Here I made adapter to secure wires. You can see, very simple adapter. So when you secure wires, then you use a cordless drill and twist it. First you twist each wire separately, twist it gently, and then put everything together and twist it to the final. After that, I put nylon protective cover to them, and then let's secure connectors. So you can see it stays flat. It doesn't make any wrinkles or rings, and this is really a good way how to make a cable. Afterwards, it stays flat to the surface as well. Even thick wires are twisted together. The final step is attach connectors. Here I took 2 new connectors. This is a package how they come, and here is 8-pin speak-on connector. It consists from 4 parts. So, and also we have some copper tubes or other metal tubes to crimp on the wires if we have a crimping tool, but it's not a must to use it. I have it and I will crimp, but I will crimp some mainstream electrical connectors. This is much easier. When you finish, your wires will not be the same length, but it's easy to fix. Just put them together and cut all of them at once. Even don't try to make them equal, it's not possible. Now we need to clean it. I'll show you it in accelerate mode, but simple procedure. Any wire strapper will fit well. It's not necessary to even crimp those extra connectors. You can just make those wires longer, and it's fine to secure with the screws. I have option to crimp it, and I like those terminals. I will crimp it, but it is not must. If you don't have it, don't worry. Simply use what you have. Connection will be great anyway. For woofer I need a double size, and I pick it from my stock. Actually, those crimping tools are not expensive. I bought them at AliExpress, and I think the price was about 20 euros. The quality is good, and you can really have that excellent wire processing. Otherwise, you need thin wires or even solder wires, but once you make this crimping type, it is really secure. And also when those screw terminals, those screws come in, and those tubes are elastic, and then you have crazy strong connection afterwards. So I think it's a relatively reliable technology. And also this small plastic cover also adds additional security when you are assembling such type of devices. I'm kind of fan. Okay, now let's put everything together. Some parts you should be cautious and put first. If you forget, then you should redo it again. But otherwise, it's straightforward process. Pay attention, there is a mark for contact number 1, and then you go counterclockwise looking from the terminal side. And in general, item by item, we can do it pretty smooth. You can see here is accelerate mode. I try to speak and then show in the same time. No way. So I'm doing this kind of a voiceover, then it's by far better. But anyway, streamline or a seamless process, and I'm pretty happy how it is went through. And here you can see, here is a first contact mark. It is a 1+, and you start with 1+ and go counterclockwise, and you will not make mistakes. For my project or for this particular cable, I will use just sticky tape, and it is secure and reliable enough. If you want to something nice looking, then you can use shrinking tubes and or other material. I saw even some advanced cables they are using aluminium kind of clamp at the end, but it's pretty secure using a sticky tape. Yeah, we can talk about aesthetics, but sometimes I'm building for myself. In this case, it's not important. When I'm planning to sell something, probably I will put a shrinking tube, and then it will look more professional. From practical application, it's not needed. But you know, sometimes we need aesthetics, especially I know, selling in Japan, in Germany. People are obsessed with nice looking things, and maybe it's right. Sometimes we need it. So now you can see that there are kind of key locks, and we should place them properly. Some of them are larger, some of them are smaller, so you can't make mistake. And when you place it, then it goes only in one position. This clamping tube, it is made pretty smart, so you can put it afterwards. You shouldn't put it on a cable in advance, and then just securing with that key lock, and our connector is done. When you put everything together, it will be really secure. It clamps those wires as a hell. They are very strong in a contact, and you can be kind of secure, even if someone will push it or pull it, no problem at all. And you can see, pretty easy to make it. Yeah. And afterwards you have really fast removable speaker cables. Your speakers will be perfectly or absolutely passive, no electronic there, and a multi-channel amplifier is connected with just one special cable. Yeah, nice. I'm pretty happy with the result. Now let's check how they fit in panel mount connector. There are key locks, and you can see how easy it is to connect, and it's really strong and straightforward. It's easy to manage, easy to move it, easy to place your speakers. I think it's a perfect solution for a future DIY projects. Yes, we can use banana type of speaker connectors, but those are not good in my opinion.